Okay, number 76 is another problem where you're supposed to come up with a possible rational and see which of those are the actual roots and then solve for the remaining. So remember the possible rational roots are the factors of the constant, factors of -5, same thing as factors of 5, 1 and 5, divided by the factors of the leading coefficient, which is again 5. So I'm really just dealing with the factors, or the possibilities of 1 divided by 1, and 1 divided by 5, and 5 divided by 1, and 5 divided by 5, which is 1. So 1, 1/5, and 5. Positive and negative. So I'm going to graph. Guys, I'm making a video, so please, I can't hear myself think. Plus 14x squared plus 22x minus 5. Shh. You don't have to be completely quiet, but you can't talk so loud that I can't hear myself think. Okay? Thanks! Okay. So, I typed in the function, and then I'm zoom 6, just go to standard window, see what happens. And, okay, the only thing I see right there is, right there. So I'm thinking it's a positive 1/5, but I'm going to go ahead and zoom in. Go negative 1 to 1. Negative 2 to 2. Doesn't really matter. And 1/5 is the same thing as 0.2. And that looks pretty good for 0.2. Ouch. So, I'm going to synthetically divide out 1/5. So I've got 3, 2, 1, 9, so 5, 14, 22, and -5. Bring down the 5. 1/5 times 5 is 1, so that's 15. 1/5 of 15 is 3. 25, a fifth of 25 is 5, and that is 0. So then I need to solve 5x squared plus 15x plus 25 equals 0. So in order to make this easier, I'm going to go ahead and divide everything by 5. So I'm dealing with x squared plus 3x plus 5 equals 0. Guys! Down. So, okay, I have a couple different options on solving this. I could do, it doesn't factor. I can't do the, well, I mean, I could do completing the square. In fact, I might go ahead and do it just for fun. Yeah, I think I'm going to do. Even though it's odd. Yeah, it's kind of fun. Okay, so I've got x squared plus 3x. To be honest, though, the most efficient way is probably going to be to do the quadratic formula, but I just want to go ahead and get another practice on completing square. So cut that in half, and I get n squared. So I've got x plus 3 halves. Quantity squared is 9/4, so I'm going to add 9/4 to both sides. That is times, so 1, so I multiply by 4 on top and bottom, so that's negative 24th plus 9/4. That's negative 11/4. Oh, thank you. So then I square root both sides, and I've got x plus 3 halves equals plus or minus the square root of 11i over 2. And then I add x equals a negative 3, or subtract, over 2 plus or minus the square root of 11i over 2. So let me prove it with the quadratic formula. Just because I can. X equals negative b plus or minus the square root of b squared. B squared is 9 minus 4 times 1 times 5 all over 2 times 1. So that's 9 minus 20, which is negative 11. So you get negative 3 plus or minus square root of 11i over 2. Same thing I got, only a lot faster and better. So it's whatever. I just wanted to do the the completing square. Okay, number 77 is where we are. I'm giving you a root, and you're supposed to use synthetic division to solve for the remaining roots. So, the one I gave you is square root of 3, and so there's an understood negative square root of 3, right? So, what I want to do is put the square root of 3 inside, and then 4, 3, 2, 1, 9. I'm missing a 3 and a 0, so I need a 0 here and a 0 there. So I've got 1, 0, 22, 0, and negative 75. And then I drop the 1. 1 times the square root of 3 is the square root of 3. That's the square root of 3 when I add. Square root of 3 times square root of 3 is 3. 22 plus 3 is 25. This is 25 square roots of 3. And the square root of 3 times 25 square roots of 3. Square root of 3 times square root of 3 is 3. And so 25 times 3 is 75. And there we go. So now I need to do the negative square root of 3. Please don't be distracting if you're not. Noah, people have to work even if you're done. So bring down the 1. Negative square root of 3 times 1 is negative square root of 3. Add and I get 0. Anything times 0 is 0. 25. 25 times negative square root of 3 is negative 25 square root of 3, which is 0. So I'm left solving the equation x squared plus 25 equals 0, which means x squared equals a negative 25, which means x equals plus or minus 5i, and plus or minus the square root of 3. Okay. Number 78. I'm given 2 minus the square root of 3, and therefore 2 plus the square root, 2 minus 3i, and 2 plus 3i. It really is your choice on which one you do first. I'm going to go ahead and do 2 minus 3i because that was the first one given, and I feel like that's what most people are going to do. But you have an option. You have the choice, and I would probably choose to do the 2 plus 3i first. But whatever. 2 minus 3i. 4, 3, 2, 1, 9. So 4, negative 12, 30, 76, and negative 78. Too bad I didn't give you more room on this problem. Okay. So bringing down the 4. 4 times 2 minus 3i, that is 8. And then negative 3i times 4 is negative 12i. So combine like terms, real with real, so negative 12 plus 8 is a negative 4, and then minus 12i, right? Now I need to multiply 2 minus 3i times negative 4 minus 12i, so I'm going to do that over here. 2 minus 3i times negative 4 minus 12i. Ladies, focus and work. Guys, you can't all have the same data. So you need to be spending and doing your own. Huh? Okay. So negative 8. 2 times negative 12i is negative 24i. Negative 3i times negative 4i is positive 12i. And negative 3i times negative 12i is a positive 36i squared, which means it's a negative 36. Negative 36 minus 8 is a negative 44. So negative 44 minus 12i. Thank you. Okay. 30 minus 44 is a negative 14, so negative 14 minus 12i. So I've got 2 minus 3i times negative 14 minus 12i. So that is negative 28 minus 24i plus, let's see, 42i, and positive 36i squared, which is a negative 36. Okay. So I've got negative 36 and negative 28, which is negative 64. 50, 64, yes. And then 24 to 42 is 18. 6 times 4 and 6 times 7, 6 times 3, so plus 18i. Oof. So negative 64 plus 18i, and so that's 76 minus 64, that's 12, plus 18i. So then 2 minus 3i times 12 plus 18i. So that is 24 plus 36i minus 36i. That's a good sign. And then 3 times negative 3i times positive 18i. So that's 30 plus 24, so 54, negative 54i squared, which is a positive 54. Those two cancel each other out, and 24 plus 54 is 78. All right. Next, we need to do 2 plus 3i. So 2 plus 3i. Bring down the 4. 4 times 2 plus 3i is 8 plus 12i, which leaves me with just 4. 2 plus 3i times 4 is 8 plus 12i, which is now negative 6, so negative 14 plus 8. And then 2 plus 3i times negative 6 is a negative 12 minus 18i, which is a 0. So I'm left with the quadratic equation 4x squared plus 4x minus 6 equals 0. Now, in order to make this easier on myself, I am going to divide everything by 2. So I'm dealing with 2x squared plus 2x minus 3 equals 0. And I'm going to go ahead and do the quadratic formula. X equals negative b, so negative 2 plus and minus the square root of b squared, which is 4 minus 4 times a, which is 2, times c, which is negative 3, all over 2 times a, which is 2. So I've got 4 minus 4 times 2 times negative 3, so I'm going to go ahead and do this real quick. 2 times negative 3 is negative 6. Negative 4 times negative 6 is positive 24, so it's actually 4 plus 24, which is 28. So negative 2 plus and minus the square root of 28 over 4. 28 is 4 times 7, so I've got negative 2 plus and minus 2 root 7 over 4, which is negative 1 plus and minus the square root of 7 all over 2. And that combined with 2 plus and minus 3i. Are all my roots. Okay. Now I've got to solve for, or condense logarithms. Okay, so let's switch gears. In general, log base b of m plus log base b of n is the same thing as log base b of m times n. That's called a product property. When two logs are separated by addition, they can be combined using multiplication. And the quotient is when they're separated using subtraction, they can be combined using division. So m divided by n. And that's inside the logarithm. Okay? So, also the power property. Log base b of m to the p is the same thing as p log base b of m. Okay, so the power can come to the front. So on number 79, it says condense and simplify. So I got two logs separated by addition, so I'm going to combine them using multiplication. Log base 7 of 8 times 11, that's 88, and I'm done. On this one, I've got log base 6. They're separated using subtraction, so I combine them using division. 2/5. There's nothing I can do, so there it is. Number 30, or 81, 30. 81, okay. So the difference between these right here and what we have going on in number 81 is that they've got a number in the front. And in order to condense, you have to move any number in the front back as a power. So this becomes a 30 right there. So we've got log base x, just kidding. There's actually no base written, which means it's an understood 10. So this is log base 10 of x to the 30th plus log base 10 of y to the 5th, or just log. And the two, combine them using multiplication, so log, I don't know why I wrote parentheses, log of x to the 30th times y to the 5th. You can write the base 10, but you don't have to. Okay. Good Lord, I'm just going to leave that problem. Okay, this goes back as a power, and that goes back as a power. I've got two logarithms. They're separated by using subtraction, so I'm combining them using division. So log base 4 of u squared divided by v to the 12th. And I cannot simplify them because one is a u and one is a v, and they have different bases. So that is as simplified as it gets. And that's page 11.